here. There's 5-2 here. You guys are going to have to pick me up out in Richmond. There's nobody here to talk. Okay, so anyway, tonight we're going to start talking about measurement. And measurement is really kind of weird. We have two measuring systems. We have what's called our standard measuring system. Used to be called the English Standard Measurement System, but back in the 1980s, England switched over to the metric system. And of course, we have the metric system. And the way the two of them developed is really kind of strange. I shouldn't say strange, it's very, very different. The standard measurement system came from a need. And it just kind of evolved and developed over time. People started using things to measure, and then over time they said, well, okay, you use this, I use this, let's compare and put them together so we can both use both of them. And it ended up being very, very clumsy. The metric system had the advantage of having the standard system being in place for literally thousands of years and being able to observe the standard system and then planning it out. It was planned. When most of the standard measurements developed or came about, nobody had even thought about using measurement in a lot of the ways that we do now. And nobody even thought about being able to compare and convert and stuff like that. They just wanted to communicate. So the metric system, I mean, most people just kind of scowl when you say metric system, but really if you look at it, because it is planned out, a lot of the weaknesses and the difficulties in the standard system aren't there because they were aware of those weaknesses and they were able to plan to eliminate them for the metric system. So we'll get to that when we get there. So we're going to start out with that standard system. And of course, the first thing that always comes up, because I brought up that whole idea that it was the English standard system, and now, well, for 30 years now, England has been on the metric system. Question always comes up, when are we going to switch over to the metric system? Well, at the risk of dating myself, probably about 28 years ago, I sat in my middle school science class, and my middle school science teacher said, we have to learn the metric system because within 10 years, we're going to be on the metric system. We're going to change the metric system. Well, 28 years, 10 years, it's gone by. Many of you probably sat in a middle school science class or a similar science class in school and were told, boy, within 10 years, we're going to make that switch. And it isn't happening. There are some things that have happened. You cannot buy a pound of tobacco or a pound of gunpowder or a liter of whiskey. Anything that is regulated by the ATF, the Department of Alcohol, Tobacco, and Firearms, is required by federal statute to be bought and sold in metric units. Our government has left it up to individual agencies to make the decision when they switch over. I believe the next one is probably going to be FDA. You see most of your food's already in milligrams anyway. Your soda and your other things are in liters or half liters. You still have your 20-ounce bottles, but if you look closely, there's also liters and milliliters marked on there. It won't be long before you won't be buying gallons of milk. You'll be buying 3.5 liters or whatever. So anyway, it'll slowly switch over. Probably the biggest thing that's stood in the way is driving. If I went out here on the highway and took down the speed limit 55 mph sign and put up a speed limit 88 kph sign, some people probably get home a lot faster tonight. 55 mph and 88 kph are the same speed, just most people don't know it. They don't realize it. It's a slow change. We've kind of backed off on it. It used not that long ago, if you look at the speedometers on your cars, you have miles per hour in big numbers and kilometers per hour in small numbers. There was a point in the late 80s where they had actually pushed to switch that. The kilometers were the bigger numbers and the miles were the smaller numbers. And all of your bolts and stuff were switching over to metric. And now it's kind of slid back again. Many of your international corporations, like IBM is one of the biggest ones I can think of, but many of your companies that produce both in the United States and overseas have switched to doing everything in metric. IBM, the first year they did it, figured it saved them more than $12 million because of the whole, having to design everything in both units. Yes, sir?
I was going to ask, aren't some countries like England still bilingual with standard and metric?
They are pretty much, but they are pretty much still using both systems, but anything that is done for international trade is pretty much done in metric units. One of the big reasons for that, and we'll come back to this later, is the standard measuring system is anything but standard. The US foot was not the same as the Swiss foot, and so on. US pound and ounce was not the same as the troy ounce and the troy pound, the Greek. And we'll get into that too in just a little bit. So we're going to start talking about, some of that you won't be tested on. I'll just mention it, and I'll let you know what parts I'm just mentioning for your information. But let's start talking about standard length. Length measurement was probably one of the first ones to develop, and it developed out of a need to communicate. Now let's say that we're both building something, and we want to build them identical. Well, if we're in the same room together, you can just walk over and hold yours up next to what I'm doing and make sure you get it the same size. But if you're down the hall or across town or whatever, I need some way to communicate that with you. I mean, I suppose I could cut a rope or a stick or something that size and send it to you. But if there's a bunch of different dimensions, that's a lot of stuff to send back and forth. It'd be nice to be able to write it down and just send it to you that way. So let's say I take this piece of paper here, and you want to make one exactly the same size. I would just take something, maybe I'd take this pen here, and it's kind of hard to see because it's black, and I'd hold it up to my paper. I'd go 1, 2, 2.5. This paper's 2.5 pens long. So I send a message to you saying, hey, the paper's 2.5 pens long. So you pull out your pen, and you measure. 1, 2, well, this piece of paper is barely 2 of these pens long. Yours at 2.5 is going to be much bigger than mine. So that didn't work. When I send that message saying the paper is 2.5 pens long, I'm making 2 assumptions. 1, that you have a pen. And 2, that the one you have is pretty close to the same size as the one I have. If these are the 2 pens, obviously that's not a very good comparison. So they started using things that, first of all, pretty much everybody had at least one of, and were pretty much the same size from one to another. And for example, in our units of length, the smallest unit of length we use in the standard system is the inch. Does anybody know where the inch came from? The inch is the length from the end of your thumb to the point of the first knuckle. That's an inch.
Everybody's is the same.
Well, really close to the same. Now there's 2 things. I mean, now there's a huge variation in height of people. Back then, the average height was much smaller. I mean, a man who was more than 5'6" was huge back then. So that people are smaller, so there's still less variation. And they did specify it was a man's thumb, because there is quite a bit of variation from man to woman. Not to sound sexist, but that was just who was doing the measurement at that time for length. So I mean, I feel uncomfortable stating that every time, but that's how it was. So again, the guy with stubby thumbs got kind of cheated. I mean, there was still some difference. They weren't identical, of course. Going larger, the next larger unit, well, the one that we're used to is the foot. And of course, that is 12 inches long. And of course, the foot is just your foot. Now, there were other units that were used quite a bit back then that are not used much anymore. Partly because the foot wasn't that versatile. I mean, we use the foot for a lot of things now that they couldn't back then. For example, if I wanted to measure the height of this wall here, well, I could get to about here if I did some serious stretching. And I'm not going to get to the top of that wall with my foot unless I chop it off at the ankle, right? It's not possible. The foot was only usable, is only good for things that were close to the ground because that's where your feet usually are. I'm not going to be able to measure heights with a foot. So they used other things like hands. A hand was the width of your hand at the base of the fingers here. That was about 4 inches. Now to this day, they still use hands for measuring livestock because that was one of the things that was common to measure in hands. You didn't want to be standing next to a horse trying to stretch your leg up in the air to see how tall it was. And it was just easy to stack your hands as you're going up and keep a measure. Another one that isn't used anymore, a little bit longer than a foot, is a cubit. Have you ever heard of that one? The cubit was from the point of your middle finger to the point of your elbow. Back then, now it's probably a little bit longer, but back then it was about 16 inches. It was a common construction unit. Think about it. What's usually 16 inches apart? Your studs for walls, your floor joists, pretty much everything in construction is 16 inches apart. That's where it came from. Everything was just 1 cubit. They'd lay down their arm, and that's where they marked the next stud or the next joist or whatever. But those units are not as necessary anymore because somewhere in the 500s, King Edward declared that his thumb and his foot were going to be the official units for everybody in his kingdom. So they came in and they cut little blocks of wood or whatever they used. They marked them on his thumb and they cut them and they passed them out for everyone to use. And they did the same with his foot. Now I could measure the height of this wall with the foot because I don't have to get my foot up there. I just take that little block of wood and you can go up there. So it was a very selfish act on King Edward's part, but it changed measurements significantly because now you didn't have to be able to get your body to where you were measuring. You could just use it was our first measuring device. Now, bigger than a foot, like we said, we had the cubit, but the next one that we use commonly is the yard. Of course, a yard is commonly known to be how many feet? 3 feet. Most people think a yard is the length of your stride if you take a healthy sized step. That's not where it is, about that long, but that's not where it comes from. Anybody know where it comes from? It's either from the center of your chest or the point of your nose to the end of your outstretched arm. If you ever bought fabric, you'll watch them, you'll grab it, pull out 1, 2, they're measuring out yards. So again, King Edward declared his arm, his reach was going to be the official yard. Now, most people do not have a 36-inch reach, a 3-foot reach. At some point, a few hundred years later, after King Edward was dead, because if you'd have messed with his foot and yard and stuff while he was alive, you'd have probably been executed. They adjusted them. There wasn't 12 of his inches in a foot, and there wasn't 3 of his feet in a yard. They adjusted their length so that they did fit together, so that they could compare. So that if you measure something in inches and I measure something in feet, we can somehow compare to see which one's longer. Before that time, there was no comparison. There was no way to know. So anyway, moving up from a yard, there were things like a furlong, it's 1/8 of a mile. A fathom was 6 feet. Fathom was for navigation. Fathom was the shallowest water they could navigate most of your many larger boats through. Literally, they threw a sailor overboard, and if he could stand up and if his head popped out of the water, it was too shallow. They didn't leave him there. But anyway, so one that is a little unusual that we are going to talk about is something called a rod. A rod is about 16 and a half feet, or 5.5, 5.5 yards. A rod was originally a shepherd's tool. Shepherd had 2 tools, a rod and a staff. The staff was that little hook, kind of like the little Bo Peep style hook you see. You used to hook an animal around the neck and detain them to shear the wool or do whatever you needed to. The rod was a defensive weapon. Literally fighting off wild animals. Now you think about that, 16 and a half feet, that's probably about twice as tall as this ceiling. That's a pretty big stick. They literally just took a sapling tree, cut it down, and took the branches off it. That's what they used. But if you think about it, if you're fighting off a wolf with nothing but a stick, I do want a little distance between us there. I'm probably hiding behind one of the sheep saying, here, take the small one. Anyway, the rod became used for measurement because, well, let's say John has some sheep and I have some sheep, and we send them down in the pasture, and at the end of the day, That's a sheep, but for those of you that can't tell. At the end of the day, John says, well, I had 12 sheep. And I said, well, I had 15 sheep, and there's 20 sheep down in the valley. Well, one of us is lying, most likely me. How do you tell? Well, for cattle and horses, they solved that by branding. Put a little mark on it. For sheep, that didn't work for a couple of reasons. One, the wool grew out too thick. You couldn't see the brand. And two, wool is slightly flammable. Just not insignificant there. So anyway, they didn't have ear tags and stuff like that. Yeah, can you imagine that? Poof, black sheep. Sorry, that was wrong. Anyway, there wasn't an effective way to mark the sheep. Ear tags and stuff weren't quite developed yet. So what they did is they'd find a landmark, maybe this big rock or whatever. And they'd say, okay, I'm going to pasture my sheep over here. John's going to keep his sheep over there. We're just going to keep them separate. That was the first land ownership, first division of land. Otherwise, pretty much everything was free range. Now, the arguments came up of, you've got more land than I do. So I would take my rod out there and I'd lay it down on the ground. There's one. John would put his on the end, and I'd put mine, and we'd just keep counting 1, 2, 3, and we'd measure out, okay, mine is 40 rods by 60 rods, yours is 40 by 60, we've got the same amount of land. To this day, if you look at a legal description for a piece of property, it'll say, the southwest corner is 18 rods north and 17 and a half rods west of a certain landmark. So bigger than rods, like you said, we had furlongs and other things. We're going to jump from there up to the mile. Anybody remember how many feet are in a mile? $5,280. How about yards? 1,760. The mile, there's a lot of stories out there from where the mile came from. One was they said it was the distance King Edward could see from his throne. But actually the most plausible explanation I've seen comes from the Greek. The Greek prefix milli, or mil, is 1,000. If you look at your taxes, the mill rate is your price per $1,000 of value. A mile came from the mill, it was 1,000 paces. Now, pace was starting on your left foot, going to your right foot, and back to your left foot, was the distance that a Greek soldier marched 1,000 paces in formation. So that works out. You think one pace, left foot, is about 5.28 feet. So those are our lengths. Now, we mentioned some of the unusual ones that we haven't seen. If I go to convert, for example, if we're going to go from like 6 feet into inches, most of us have done that enough that you might even be able to just yell out how many inches that is. Anybody? There you go. At the very least, you can just say 6 times 12 is 72. Right? You don't have to go through any formal conversion. You know that you get from feet to inches, you're multiplying by 12, and from inches to feet, you're dividing by 12. So we don't really need to do a formal conversion there. But if you didn't know that, here's what we would do. We'd take our 6 feet and we would make it into a fraction by putting it over 1. I know fractions. It's not as bad as it looks. Conversions? Okay. Now what we're going to use is we're going to use an equality, an equivalency. We say 1 foot equals 12 inches. We can use that equivalency to create a conversion factor. Now we're getting rid of feet. So to make them go away, we're going to put them on bottom in this second fraction so that they will cross cancel out in our multiplication. So that means the inches have to go on top. 1 foot is 12 inches. So now we have 6 times 12 is 72 inches. And on bottom, 1 times 1 is just 1. So 72 inches over 1 is just 72. The reason that works, by the way, 72 inches is the exact same value as 6 feet. We have not changed the value, we've just changed its appearance. The reason that works, if we think back to when we first did fractions, if I had 3/4, I could multiply the top and bottom of that by the same number. 3 times 5 is 15. 4 times 5 is 20. 15/20 has the exact same value. It just looks different. Because what we multiplied was 5/5, which equals 1. And anytime you multiply by 1, you get the same thing. You don't change the value, but you can change the appearance, as we saw there. Well, 12 inches over 1 foot looks like it's not equal to 1, but it really is, because 12 inches and 1 foot are equivalent. They're equal. So 12 inches over 1 foot is still really, it's a unity fraction, as we said. It's still equal to 1. Now, if we look at a conversion that you might not be as familiar with, let's say 99 feet into rods. That's when you probably can't just throw out there, oh, I'm going to multiply or divide or whatever. But let's do this. 99 feet over 1. And my conversion factor, what's going to go in here? Well, on bottom, we're going to put, the feet are going to go on bottom, because they have to cancel out. And yes, it is going to be 16.5 feet. On top, we'll go run 1 rod. But the biggest thing is we've got to put whatever this unit is here that we're trying to get rid of, it has to go on bottom so they cross cancel out in our multiplication. So the feet go away. So now we have 99 times 1 rod is 99 rods. 1 times 16.5 is 16.5. And we divide that out. 99 divided by 16.5 is 6 rods. So there we could do a conversion with units we're not familiar with. Especially later on when we get to converting from metric to standard or standard to metric, those conversion factors like that are going to be very, very important to us. Next thing I want to discuss is weight. Now, to discuss weight, we first must discuss the difference between weight and mass. They are not the same thing. Weight is the force of gravity on an object. Mass is the amount of material in an object. Amount of matter is the technical term. The number of particles and how tightly they're packed in there, that's the mass. The way they are measured, weight is measured, literally the force of gravity, it's measured against a spring with a known force constant. So you take a spring and you hang the object on the end of that spring. Then on the spring there's an indicator, and the distance that indicator moves is read on a scale that we can, a number scale where we can see, okay, that's how much this weighs. That's the force that gravity is pulling on this object. Mass, on the other hand, is measured on a balance. Pretend that looks balanced. We put the object we're trying to measure on one end, and then we put a known mass on the other end until it balances. And when it balances, whatever this known mass is the mass of the object on the other side. Now you might be looking at that thinking, well, what's the difference? Well, on Earth, gravity is relatively constant. It's slightly less gravity at the equator and slightly more gravity at the North and South Pole. But it's really close to being constant. So on Earth, we tend to use mass and weight interchangeably because if you double the mass, you're going to double the weight. But let's say you were to go to the moon, where gravity is significantly less. What's going to happen to the weight of this object? Well, it's not going to pull near as much. So the indicators, the spring isn't going to stretch near as much, and it's going to weigh a lot less. Now on the moon, gravity is going to pull on this object a lot less too, but it's also going to pull on our known mass. So the mass will stay the same on the moon. Mass does not depend on the amount of gravity, because literally the amount of particles or matter in that object. Now that seems like a subtle difference, but the reason I'm pointing it out is in the standard system, we tend to rely on measuring weight. our main unit of weight, well, let's start out with our large unit of weight that we use, the ton. How big is a ton? 2,000 pounds. Now, technically, that is what we call one net or short ton. Now, if there's a net or short ton, it implies that there is one gross or long ton. A gross ton is 2,240 pounds. Now, to clarify, 99.99999% of the time, when you hear the word ton, they're talking 2,000 pounds. In this class, every time you hear the word ton, think 2,000 pounds. I would never put anything on a test or a quiz other than a regular short ton, net ton. Why is there a difference? Well, if you think of your paycheck, you have your gross pay. If you work 40 hours a week at $10 an hour, your gross pay would be $400. That's what you earn. That's everything. But you don't get that much, do you? They take out taxes and other stuff, and you actually you might get a paycheck of $280. That would be your net pay, what you actually get. Tons were originally used for measuring and buying and selling grain. Well, you can't just put 2,000 pounds of grain on a scale. It spills off. So you had to put it in a container. The container that held about 2,000 pounds or about 1 ton of grain weighed about 240 pounds. So the gross ton was with the container, and the net ton was without the container. So for the most part, we don't use the gross ton much anymore. But I wanted to throw that out there because you may run into it at some point. Smaller than a ton, or next we had the pound. Smaller than a pound, we have what? Ounces. Anyone know how many ounces in a pound? 16 ounces in a pound. I should note here, the abbreviation for pound is LB. It would make sense for it to be PD, wouldn't it? Pound. Unfortunately, in the bookkeeping system they had for buying and selling grain, PD was already used for paid. Really not good to mix those two up. So LB comes from the Latin word libra, which is the Latin word for pound. So they decided to use the Latin word instead of the English word. The abbreviation for ounce then is OZ, which comes from the Latin word for ounce. And at the moment, I cannot think of that. So you'll just have to trust me that that's the right abbreviation. There is a unit smaller than an ounce that we use. It sounds metric, but it is not. It is called a dram. 1 ounce is 16 drams. The dram was one of the original apothecary units. By apothecary units, I mean measuring out drugs. For your pharmacist, your doctor might prescribe a 16th of a dram of a medication, or a half a dram of medication is a really powerful dose. There was also a unit in there called a grain. 7,000 grains equals 1 pound. If you're wondering why I always underline pound, LB, when I abbreviate pounds, it's just so you don't confuse the L as a 1. So anyway, 7,000 grains is 1 pound. Now grains, because they were so entrenched in medicine and measuring out medications, has been adopted into the metric system. Not very smoothly, but if I remember, we'll take a look at it. It's not one that you need to know because we're not going to get into the grains for this class. Another thing that you don't have to write down that you don't need to know, but I'm going to mention just because you will run into it. You hear a lot on the news about buy gold and buy silver. And gold is up to $1,800 an ounce or whatever. They're not talking about these ounces and these pounds. We talked about how King Edward got the idea to standardize all the units by taking his thumb and his foot and whatever. And he did similar things with pounds and ounces, made those standard based on what he had. Well, other leaders in other countries did the same thing. Other countries ended up with pounds. There's a British imperial pound which was away from King Edward, which is slightly different than a regular pound, slightly larger. Precious metals were commonly bought, most common, the center for trading precious metals, I should say, was in the Mediterranean Sea off the coast of Greece and an island called Troy. So, you ever heard of the Trojan horse? That was the island of Troy. So we use Troy measure for precious metals. And again, I'm just throwing this out there for your information. We'll never be tested on this one. 1 Troy pound is about 0.82 regular pounds. So you can see it's smaller than a regular pound. However, 1 Troy pound only holds 12 Troy ounces. So a Troy pound is slightly smaller than a regular pound. A Troy ounce is slightly larger than a regular ounce. Again, that's just for your information. We won't be tested on that. Okay, so enough on weight. Let's talk about mass just briefly. There is a standard unit of mass. Most people have never heard of it. I said briefly because I'm just going to throw it out there and we're not going to do a whole lot with it. The standard unit of mass is called the slug. If you ever hear someone say, he took a whole slug of those, that's what they're talking about. That's where that saying came from. 1 slug was about 32 pounds. So something at a mass of 1 slug weighs about 32 pounds. And that's all we're going to say about mass for the standard system. We're going to move on to capacity. Capacity and volume are often used equivalently. They are not the same thing. Volume is defined by length measurements. Like you could define the volume of a box by taking its length and its width and its height. And you use those 3 measurements to calculate the volume of a box or whatever it is you're trying to calculate the volume of. Capacity is a set size. And we're going to start out with 1 gallon. A gallon was actually about the size of a standard man's hat. Now, you ever hear the phrase 10-gallon hat? That's not referring to a hat that doesn't actually hold 10 gallons, just a really large hat. So it's kind of the saying, oh, it's a 10-gallon one. No, not really holding that. But a standard hat holds about 1 gallon. Smaller than a gallon, we have a quart. Does anybody know how many quarts are in a gallon? 4. The word, and the way you remember it, the word quart actually derived from the word quarter. It was a quarter gallon. So there are 4 quarters or 4 quarts in a gallon. Smaller, oops, don't know where that came from. Smaller than a quart. 1 quart contains how many pints? 2 pints in a quart. A pint. A little note here, by the way. The abbreviation for pint is PT, quart is QT. In some type fonts, a Q looks like a backwards P. So be careful with those. I do see those mixed up a lot. 1 pint. Smaller than a pint, we have cup. And 1 pint is 2 cups. A cup actually was originally called a half pint. There are actually other sizes of cups defined. There's teacups. There's other things that are defined for cups as well. But a standard cup is half a pint, 2 cups in a pint. 1 cup. Anybody know how many fluid ounces? 8 fluid ounces. Very good. Smaller than a fluid ounce, we have 2 tablespoons. Smaller than a tablespoon? Teaspoon. Anybody know how many teaspoons in a tablespoon? 3. Very good. If you do any significant baking, those are good ones to know. A little bit of a note of warning there as well. The most common abbreviation right now for tablespoon and teaspoon is just capital T for tablespoon and little t for teaspoon. But there have been several. Teaspoon has also been abbreviated TSP, where tablespoon is sometimes abbreviated capital TSP, and sometimes abbreviated with a small t, BSP. So be careful. Trust me, if you're making cookies and it calls for 3 teaspoons of salt and you screw up and put in 3 tablespoons, they're no good. If you can look at me, I've not thrown away too many cookies in my life. That batch went in the garbage. I could not, no matter how hard I tried, they could not go down. And I tried, trust me. Even milk didn't do it. Okay, now at that point, you don't need to know the rest of these. I'm going to throw them out there just for fun. There is a unit smaller than a teaspoon called a dash. There are 2 dashes in a teaspoon. A dash is just, we have salt and pepper shakers, but they had the large spice shakers back then. One big, tip and dump out of the 1 dash out of the shaker was 1 dash. Smaller than a dash. 1 dash contained 3 pinches. Very good. A pinch, you stuck your fingers in there, pinched them together, and what was between your fingers was a pinch. You threw it in. And smaller than a pinch, 1 pinch was 2 smidgens. I have a good friend of mine who's a caterer, actually has measuring spoons for all those. A smidgen, and this one I don't like to think about this one because it's kind of nasty. Stick your finger into the spice and whatever stuck to your finger, you wipe that off into the recipe. That was a smidgen. So the baker with really sweaty fingers had big smidgens. Yeah, hey, I didn't make it up. Oh, bigger than a gallon. One that you've probably heard of is a bushel. Everybody know how big a bushel is? 8 gallons is a bushel. How about a peck? Two gallons. The old tongue twister, Peter Piper picked a peck of pickled peppers. That's 2 gallons. Or a lot of times you pick strawberries or something like that, they'll have the crates out there that are the 1 peck or the 2 peck crates. That's what they are. It's 2 gallons is a peck. This one's always a fun one. You know how big a barrel is? It used to be every college student knew this one. Anybody want to throw one out there? Usually the one that's thrown out is 55. 55 gallons is a drum. A barrel is 31.5 gallons. It's probably a good thing that students don't know that one as well as they used to. Probably a promising sign. So those are our units of capacity. Now we said volume was a calculated unit, but you can see how a gallon and could be thought of as volume because it's how much something holds. But volume was technically the combination of 3 directions of length, 3 dimensions of length. So volume was measured in cubic feet or feet cubed. No. Volume and mass are related by density, though. Like density might be 7 pounds per cubic foot. So that means for every cubic foot of volume you have 7 pounds of weight. Technically, it should be, 0.7 slugs per cubic foot would be a technical density, but we tend to throw weight in there instead of mass. So cubic inch is then also used for volume. To relate those to capacity, cubic inch, of course, is 1 inch by 1 inch by 1 inch. a cube with 1 inch on each side. 1 gallon contains, I'm going to do this, it's approximately 231 cubic inches. This next one is the one that always kind of amazes people a little bit. 1 cubic foot. Now, if you think of a 5-gallon bucket, do you think that is more or less than 1 cubic foot? So a lot of people are about the same, maybe a little more, a little less. A 5-gallon bucket is actually considerably less than a cubic foot. 1 cubic foot is about 7.48 gallons. So a 5-gallon bucket is only about 2/3 of a cubic foot. Okay, so we can convert with those standard units in any of those. We looked at it briefly with length, but let's say we wanted to know 3 quarts is how many pints. Now again, most of us know a quart is how many, 1 quart holds how many pints? 2. So you could probably do it without setting up a formal conversion factor. But let's do this. 3 quarts over 1. Now I'm going to put quarts on bottom here so that they cancel out. Pints on top. 1 quart equals 2 pints. So now the quarts do cancel out. 3 times 2 pints is 6 pints over 1, which is just 6 pints. That wasn't so bad. 1 quart equals 2 pints. You'd have to look it up.
Oh, okay.
Yeah. You would have to know, have that information to do conversion. So that one wasn't terrible, but a little, by the way, something you can always double check. Let's say you're looking at this and you know quarts and pints and you know that 1 quart is 2 pints, but you can't quite remember, do I multiply to get from pints to quarts to pints, or do I divide? Well, look at the units. Is a quart bigger or smaller than a pint? A quart is bigger, so the unit is getting smaller, right? Go from a quart to a pint, the unit's getting smaller. The unit gets smaller, the number has to get bigger, larger, so you're going to have to multiply the number. Very good. Where it's a little trickier is if we have something like, say we have 2 quarts, and I want to convert it into cups. Well, now, I put my 2 quarts over 1. Do I have an equivalency between quarts and cups? No. So I have to go from what I can do, what's closest to cups from quarts is pints. And again, we have to either look up or know 1 quart is 2 pints. But we don't want to be at pints. Right now the quarts have canceled out. But we're at pints. And we don't want to be at pints. We want to be at cups. So we're going to put pints down here to get rid of them. Do we have a relationship between pints and cups? Yeah, we do. So we're going to put cups on top. 1 pint is 2 cups. So now we see that the quarts did cancel out. The pints do cancel out. And we have 2 times 2 times 2 cups is 8 cups. We have 1 times 1 times 1 is 1. So 8 cups over 1 is just 8 cups. We run into the same type of situation if we were converting with time. Let's say we had 7 hours. And I want to know how many seconds is that. Seems kind of outrageous, but let's do it. 7 hours over 1. We're going to put hours on bottom, but our relationship from hours, we don't have a direct one from hours to seconds. We would normally go from hours to minutes. 1 hour is 60 minutes. And now we want to get rid of the minutes. Minutes on bottom going to seconds. 1 minute is 60 seconds. So now the hours cross cancel, the minutes cross cancel, and we are going to be left with just seconds. 7 times 60 is 420, times another 60 is, what, 2,520? Or, yeah. What's that? 2,500. Forgot a zero. There we go. 25,200 seconds. And on bottom, 1 times 1 times 1 is 1. So it's just 25,200 seconds. What do you think? Not too bad? Okay. Well, it is about time. We're a minute or two early here, but let's go ahead and take our break here. It's about 4:18, so we'll start up about 4:28.